So in this assignment, this was in wave function assignment 6, you had to do this question here, which was actually from the 2019 higher paper 2, question 6. So first bit was standard wave function type question, express 2 cos x minus 3 sin x in the form k cos x plus a. So you're directed to this expression here, and that's how you begin the question. Notice there's also a part B, and the part B begins with the word hence, solve, and that should lead you into the route that whatever you're doing in part A, you're then going to be following through to make you solve in part B. So expressing 2 cos x minus 3 sin x equals k cos x plus a. That's how you begin this, so you should have those two things written down. And then of course it is about looking for the formula for the cos a plus b expansion. So you'd go to your formula list to do that, and notice here at the side cos a, the one with the plus and minus b in it. Always remember that the signs on these are the opposite way round when you do the cos expansion. So we've got k cos x cos a, and it should be a minus that we're using. When you've got a plus inside the bracket, it's a minus when you expand. K, so minus k sin x sin a. So that's how you earn the first mark in this question. Now after that, it is about making sure you equate your coefficients. So just as a matter of course and procedure, you're looking on the left hand side here, you've got, there's your cos x term. This of course here is your cos x term. What's either side of that is your k cos a. So that's what's multiplying the cos x, and then there is your sin x term, and here's your sin x term in here. What's round about that is k sin a. So having got your multipliers or your coefficients of each of those terms out, you're then comparing it with left side, right hand side. So basically what you're looking for is what do you need to replace k cos a with and k sin a with so that they match this expression. So you've got 2 cos x, so that would tell you that you would need to have a 2 in there. Your signs are matching, you've got minus, so all that you would need to replace the sin x with would be, sin a rather, is 3. So that produces from that, when you do this equating coefficients process, you get that k cos a would need to be equal to 2 and k sin a would need to be equal to 3. So not minus 3, 3, because the signs matched, and all that you're doing is looking at what would you need to put in those bracket expressions to match this expansion. Once you've done that, you're then on to finding your values for k and a. So here, as always, my procedure is that to work out the value of k, what you're doing with these two equations is you're squaring and adding. So, and that produces k squared equals 2 squared plus 3 squared, so we get k squared equals 13, so we're going to get k is equal to the square root of 13, and we of course leave it in surd form. When we do these questions, we're always interested in making sure the k value is just a single numerical term, and if that needs to be a surd, that's how you leave it. You're then looking at working out your value for tan, so tan a is always about taking the value for k sin a over the value for k cos a. So making sure you get them the right way round. So when you're looking at this, you've got tan a would be equal to 3 over 2. You can see there that the cos is positive, the sine equation is positive, and therefore the tan's positive. So basically when everything is positive like that, you're going to be getting the angle in the first quadrant. So you're simply going to go to calculator and do tan to the minus 1 of 3 over 2. And if we do that, that will give us our angle of 56.3099, whole load of other digits, and we would round that to 2 decimal places. That would be 56.31 degrees. And remember at this point that we should be writing down our expansion term. So going back to the original equation, we had 2 cos x minus 3 sin x, and that is equal to square root of 13, and we've got cos x plus the 56.31 degrees. So just check, right, that read your question again. Express in the form k cos x plus a. So that's what we've managed to do at this point. And as I said, where the marks are awarded to, right, these are standard routine. First mark is for writing down the correct expansion. The second mark is always for getting the 2 equations correct, and you need to state these equations. They can't just be implied in your tan statement. You actually need to have them written down, and then separate into working out the third value for your k, and the fourth mark doesn't come till you've actually written the expression down, including the angle of A. So once you've done the first bit, you're now moving on to part B, and of course I mentioned this already, right, that key thing about hence solve. So you've got the 2 cos x minus 3 sin x equals 3. That means that they are looking for you to replace, right, to solve a trig equation that's got 2 different trig functions in it. That's too difficult in that format, so what we do is we replace the cos and sin with just our single cos expression, and when we've got that done, we can then rearrange it to just get a trig equation that's just got a single cos expression. And then from there it is about solving that, and of course the cos is positive, so in our cast diagram that would mean we're looking for an angle in the first and also in the fourth quadrant. So of course in the first quadrant angle you would be looking to do cos to the minus 1 of 3 over root 13, and that would give us a value of 33.6900, all of the other digits, so we would round that to 33.69, but of course that's only one of the values. So our second value for our fourth quadrant, you would do 360 minus that value, and that would of course give us 326.31. Now both of those values are what the bracketed expression is actually equal to. So this here, 33.69, and this one is what that whole bracket must be replaced with in order for that to be a true statement. So what that sets you up with is that allows you to then form your 2 equations, so you can write down the x plus 56.31 would be equal to, in the first instance, 33.69, and the second one would be your x plus 56.31 equal to the 326.31. Now this left hand one here, if you solve that, you do end up with a negative value from you subtract the 56.31. So we get negative 22.62. We'll come back to that in a little minute. This one here, that would, when you subtract the 56.31, you would get the value of 270. Now, clearly, we're normally, if possible, looking for as many solutions as we can. This is a cos function. It will have a period of 360, but of course it's a phase angle when it's shifted, but that does mean that you still need to consider all possibilities. So here, what we do, because this is outside the interval, you still can find the next one along, the next wave cycle along, by adding on the period. So the period for a cos graph is 360, so we add on that 360, right, which is the period for the cos function, and we will get the value of x equals 337.38, and of course that is within the interval that we're looking for. So your final solution is these two values of x equals 270 and also the 337.38, and that would be your two values in your interval. And in this question, how you get your marks, your very first mark is for rearranging that equation with the replacing, making the link to part A, replacing with the cos, and getting your single cos expression. After that, you're looking for your two values, right? That would be your second mark, and that would be your third mark.